composite figures. So composite figures are shapes that are built up of multiple shapes. Okay? Now, this figure here, does anyone know what this could technically be a shape? The greater outside of this shape. What could we call that? That's right. This is a trapezoid. And at the end of this, I'll go into a formula on how we can actually find the area of a trapezoid. But we're going to start with perimeter. And the trapezoid can be made up of, what would this middle shape be? Rectangle. And these two? Yeah, two triangles. Okay. How do we know that this is not a square?
They have parallel lines.
Oh, they're definitely parallel lines.
No, they don't.
Because they're not all
Not all sides are equal. Good. Okay. So that means this is a rectangle. It's not a square in this case. So to find perimeter, what are we specifically looking at? Are we looking at the distance around all of the shapes involved? Yes?
No.
Yes or no? Who says yes?
Yeah.
Two people? Who says no? Why not? Who can tell me why not?
Because you're just looking to the outside of every shape, not not inside the shape.
That's right. So if we're looking for perimeter, we're looking at the outside of this shape. Okay. Perimeter, and I guess one shape is easy to see it in. Perimeter would just be all of the lengths added up. So if we had a square, we would add all four sides together. What is perimeter of a circle called? Circumference. That's right. Circumference is perimeter of a circle. So we're going to have to get into finding all of the sides of this. Okay. I'm going to highlight exactly what we're looking for. Okay, so we just highlighted the perimeter of this object. So let's talk about the length of many of the sides. We know that this distance here is 12. This little distance here is 4. This distance here would be considered what? 24. From here to here on top is the exact same in a rectangle as the bottom of it. So whatever this is, these two side lengths are the same. Okay. And in terms of perimeter, that's all we really need for this. So this will be 24 centimeters. So the entire base of this object, how do we find the distance of the base of this object? Yeah, that's right. We would add all three together. And what will we get? 40. Good. So the bottom of this is 40 centimeters. The top is 24. We're missing two parts. This side length and this side length. How do I go about solving this side length here, Travis? Yeah, what was the formula we learned yesterday? Do you remember what it's called?
A squared. C equals A plus B squared.
A what?
B squared equals A squared.
That's right. It's Pythagoras Theorem. Okay? Because this is considered what side of the triangle? Hypotenuse. That's right. So this is the hypotenuse. So we're going to use this formula twice. Okay? So I'll call this one here, we'll call this triangle 1. Okay? This guy over here will be triangle 2. In triangle 1, we have our formula. We know that c squared is equal to a squared plus b squared. C squared, or the c side, is the hypotenuse, is what we're looking for. So we'll call it x in this case. It's an unknown. So we're going to replace a, b, and c with our values here. So x will be replaced, and I'm just going to postpone that. X, or c in this case, will be x squared. What will a be?
12.
Which one's right? They're both right. It doesn't matter which one I call A or B. They're both legs of the triangle. Okay, so, well, sure. Let's go with 16 is A, and we'll go with B is 12. So, let's equate these. Anyone know what 16 squared is?
32. Hold on. 256.
That's right. 256, okay? 12 squared is 144. We're going to add the two of these together.
400.
400 on the dot? Excellent. Are we done? Is that what the distance of that side is? That's right. We need a square root. So we square root that side. Square root of 400 is? 20. Good. And what's the unit of measurement? Centimeters. Excellent. Okay, so we've just figured out that now this side length is 20 centimeters using Pythagoras Theorem. We have to use this exact same theorem. Now I have a problem. I only have the measurement of the bottom of this. What is the height of this, Travis? That's right. We have our rectangle here. So we know that this is 16. This side length is technically the same as this side length here. So we know this is 16 centimeters. So, same idea. We set up Pythagoras Theorem again for triangle 2. Triangle 2 we'll do in blue. It's still c squared is equal to a squared plus our b squared. Again, let's replace everything. In this case, I'm going to call this side length y. Okay, I need to call it a different variable. Give it a different variable. Why do I need it to be a different variable? I don't get confused yet. If I were to call this x, technically what that means is this side length and this side length are the same. Is that going to be the case? No, they're definitely not. So I need to use a different symbol to represent that. Okay, so we'll call that y in this case. So y replaces c, y squared, is equal to, what will a be?
4.
Sure, let's go with 4. And b will be our 16. 4 squared is? Good. 16 squared is? Good. Together, what are they at? That's right, good. Now, like we said, we're not done. We'll need to square root this. Right. What is the square root of 272?
16.49.
Yeah, let's round it to 0.5. Okay, so approximately 16.5. So our y is 16.5. So now, let's talk about the information we have. The perimeter is what we highlighted in yellow. Okay, so that's 20 plus 24 plus 16.5 plus 40. So let's write that out. The perimeter is equal to our base, which was 40. Okay. Our first hypotenuse of our triangle, which was 20. The top of the triangle, which was 24, in case you didn't remember. And the other side of the triangle, which was 16.5. 100.5, great. So the perimeter of this trapezoid is 100.5 what? Is it squared? No, it's a distance. It's not an area. So because it's a distance, it's only centimeters. That's all we're measuring.